The atom. Matter has mass and takes up space. Atoms are basic building blocks of matter and cannot be chemically subdivided by ordinary means. The word atom is derived from the Greek word which means indivisible. The Greeks concluded that matter could be broken down into particles too small to be seen. These particles were then called atoms. It was until the period between 1890 and 1932 when three scientists, namely J.J. Thomson, Ernest Rutherford, and James Chadwick, discovered that there are smaller particles that the Greeks did not discover. These extra small particles are found inside the pieces of atoms. These subatomic particles are called protons, neutrons, and electrons. Protons and neutrons are held closely together by strong forces at the center of an atom. Together they make up the nucleus, which accounts for nearly all the mass of the atom. Electrons move rapidly around the nucleus and constitute almost the entire volume of an atom. In the 21st century, scientists have also noted that these subatomic particles are made up of other tiny particles, and everything is then divided into energy which vibrates at different frequencies. Now we're going to look at definitions and explanations. An atom is a small particle in the universe which can be used in making bigger particles. Proton number or atomic number is the number of protons in an atom. Nuclear number is the number of protons and neutrons in an atom. The same applies for relative atomic mass, where for the relative atomic mass, it is the sum of the mass of protons and neutrons in the nucleus of an atom. Isotopes are atoms of the same element with the same proton number but a different number of neutrons. Now we're going to look at the structure of the atom. To start us off, we're going to look at the diagram in the top. And we have an electron which orbits the nucleus. In total we have around 3 in the diagram. And then we have the tiny nucleus, so tiny, and it's at the center. It is composed of positively charged subatomic particles called protons and neutral subatomic particles called neutrons. This diagram is not to scale, so our protons are the brown ones and the neutrons are the blue ones. And then you may be wondering what's around the nucleus, or between the nucleus and the electrons. There's just empty space. And then we have the path of the electrons. Don't worry, it's not so clear, but you understand it with the shielding that we're going to be analyzing, the diagram at the bottom there. So we go to the 2 points that are at the bottom. The first one is the number of protons is equal to the number of electrons, so the overall charge of an atom is 0. So they cancel each other, the charges cancel each other. Then the second point is a universally accepted structure of an atom is the one with electron shells, is the one shown at the right, the one you see there, which is the one for neon. This simple diagram helps with electron configuration and analysis of energy levels. The first inner shell holds a max of 2 electrons. The second shell holds a maximum of 8 electrons, and it goes on and on. Valence electrons are the electrons in the outermost shell, and they determine the stability or reactivity of an element. We'll get deep into that when we look at different reactivity, like in the reactivity series, and the different reactions that we'll encounter during the course. And we'll look at the table that's at our right. So you may see that there are empty spaces, so for now I'll allow you to pause the video and fill in the spaces using the information that you have gathered so far. Try and fill in the spaces, and yeah, you will play as we review your answers. Okay, welcome back. So we're going to look at your answers. I hope you got everything correct. So let us look at the headings. We have particle, relative mass, and charge. So let us look at the first particle, which is the proton with the small letter p. The relative mass is 1 or 1u, where u is equal to 1.67 times 10 to the power negative 27 kgs or kilograms, depending on the way you want to say it. Then charge, its charge is positive. It has a positive charge. So if you got everything correct, give yourself a tick. Well done. The second particle is the neutron with the small letter n as its symbol. Then relative mass is 1 or 1u, where u is equal to 1.67 times 10 to the power negative 27 kilograms, just the same as the proton. Then it does not have a charge. It is neutral, it has 0 charge, that's why we have 0 there. Then for the third one, we have the electron, which is the symbol E, small letter E. Its relative mass is 0 because it's, you can say 0 because it's negligible. It's very small, pretty small. Or you can say it's approximately 1 over 18 1833, 1833, or 1833, depending on the way you want to say it. Or you can say it's 1840 if you want to approximate it to 4 decimal places. Or you can say it's 0.000545 U, where U is also equal to 1.67 times 10 to the power negative 27 kilograms, and the electron has a negative charge. If you got everything correct, well done, you're a genius. If you didn't get everything correct, don't worry, you're also a genius, but you know you'll get it next time. So what are isotopes? Isotopes are atoms of the same element which have the same number of protons, the same number of electrons, but their number of neutrons differ. So for example, we have oxygen, and its atomic number is 8 and its nuclear number is 16. So as we all know, the atomic number is the number of protons and also the number of electrons. So our protons are equal to 8 and our electrons are equal to 8. But for our neutrons, the neutrons are equal to the difference between the nuclear number and the proton number, or the atomic number. And the difference is 16 minus 8, which is 8. So everything is just equal to 8. And then each isotope also has 8 protons, 8 electrons, but it has 10 neutrons. Why? Because their nuclear number is actually 18. So 18 minus 8 is equal to 10. So for our second example, we have chlorine. Chlorine has an atomic number of 17 and 35 as its nuclear number. So our protons are equal to 17, electrons are equal to 17, then 35 minus 17 is actually 18. So when we look at its isotope, we'll see that it has the same atomic number, but the nuclear number is different. It has 37. So it's just an increase of 2 neutrons. So we have protons equal to 17, electrons equal to 17, and then we have 20 neutrons, which is actually 37 minus 17, which will give you 20. I hope you have understood that. Let's move on. Now let's look at the periodic table of elements. The first recognized periodic table was the one created in 1869 by a Russian chemist called Dmitry Mendeleev. There were a few tabulated elements on it, but the best part was he managed to predict the existence of missing elements using the pattern in his periodic table. Some of those elements were then discovered in the early 21st century, which is more than a century post the creation of Mendeleev's periodic table. This periodic table helps scientists, particularly chemists, to predict properties of elements and how their atoms behave in different reactions. In the near future, we will look at the periodic table in detail. Thank you for watching. Nashukuru sana.